Question 2. This is a full boat manufacturing company, and we have a bunch of accounting information and some growth rates and a corporate tax rate, and we want to know the present value of the expected dividends, and then we also want to change the valuation in year 6 to 11 times earnings, and then figure out what we're going to pay. Okay, so you can call it revenue. Let's call it, what do they call it here? Sales, duh. Sales is 115. Cost of goods sold is 50. EBITDA is going to be the difference between them. Depreciation is 6 and interest is 11. So this gives us EBIT. This gives us pre-tax profit. We have to pay taxes on that. Let's put a tax rate. Make sure that's correct. Yeah. R is 0.13. Shares outstanding is 5.5 million. Okay, this should be, yep, 38. Okay, so let's just do a quick earnings per share. We're not going to need it right now, but it's really easy to do, so let's just do it. Lock that. Okay, so now we need to calculate free cash flow, and we do that by taking the post-tax income, which is 37 million. Then we add in depreciation. Then we subtract additions to working capital, which according to this is 12 million. Oops, plus depreciation minus working capital. And this will give us our free cash flow. And then we will be able to pay dividends on that. Dividends per share is going to be 31 divided by 5.5. Make sure you lock that, and we get 580, which is what we have for our solution. All right, so now we have a growth rate of 14%, and it decreases by 2% per year until we get to 6%, at which point it stays constant forever. So the easiest way to do this is to take every cell that you had originally, lock the row, and then copy and paste the formulas over. So I'm going to add borders where we need borders. And there's one right there. And then dividends, we should be able to just copy over. And I'm going to do this through year 9. Why not? All right, 933 should be the terminal dividend in year 6, which is what we have here. Okay, so the question is, what is the expected value of the dividends? Well, all we need to do, so we have year 6, this is when the permanent growth starts, and this is a perpetuity. So if we were to sell this, it would be R minus G. So the sum of our cash flows would just be that plus that for each year. And now we're assuming that these cash flows kind of go away. We don't have to think about those cash flows anymore because they're already valued in this number. And so once we do that, we just get the PV and the NPV, and we end up with 97.58, which is the solution. All right, next question is just if I sell it at 11 times the projected earnings in year 6, what is the expected value of the dividends? Okay, so I'm going to copy the years down because it's a little easier to see. And then I'm going to link to the dividends, but I'm only going to do it for 6 years. Okay, so this is dividends, and then this is the sale price. And we're going to sell it for 11 times the earnings per share, which is $11.09. And then we'll get the sum of our cash flows. So for years 1 through 5, we only get dividends. In year 6, we get a dividend, and we sell it the day after the dividend. Our PV is going to be that divided by 1 plus. Our NPV is going to equal the sum of these. And we get 88.25, which is the answer, 0.28, which is the answer here. Okay, so let me just go over this one more time. In this example, we valued the stock based on the dividends. And so we said in whatever year we reach constant growth, that we would value it as a growing perpetuity, and that's what this 133 is. And so the assumption is that these cash flows are already priced in the 133, and so that's why we only calculate the first 5 years, because terminal growth begins in the 6th year. We can value it that way. In the second part of the problem, we assume that we sold it in year 6 for 11 times earnings, and so therefore, or that we could sell it, and therefore that's the price that we would get in year 6 because earnings are $11.09. We summed the cash flows in both examples across the years, and then we took the PV and got the NPV of each of those, and that's how you solve this problem.